Hello and welcome back. So before we try to play with the threshold, here we have seen how to play with the threshold and probability and made the model work best, right? All the records got classified correctly here, right? So practically how to implement this. Before we know that, let us try to look at how to calculate probabilities and decision scores. In scikit-learn, we have got a method called predict_proba on the SGD classifier, which actually gives you probabilities for 0 class and 1 class. The first column belongs to 0 class and the second column belongs to 1 class. The predict_proba method takes the input values. It is like predicting only, right? The logistic regression's outcome is going to be a number between 0 and 1. That number is being shown as the output here, right? So to predict, generally you pass inputs and make prediction, right? So like that only. To see the probabilities also we are passing the input values. To actually use the method predict_proba, the logistic regression function should be trained using the loss function, log loss function only. By default, the loss function is hinge. We'll try to understand what is log loss in coming session. But if you use log loss, then only you can use the predict_proba method. If you use hinge loss, it is going to throw error saying that you need to use log loss while training the model. And to calculate decision scores, what are decision scores? The signed distance between the decision boundary and data points. If it is negative, the record belongs to negative class. Positive, the record belongs to positive class by default, because 0 is the threshold. So to find out the decision scores of each record, you can say decision function and pass the inputs. For each record, there will be one score outputted. If the score is negative, the record belongs to 0. If the score is positive, the record belongs to positive. In this case, negative means it is not 5. Positive means the record belongs to 5. So we have seen how to find out the logistic regression's outcome. Especially the second column is the logistic regression's outcome. It is going to give you the one class probability, and the decision function will actually give you the decision scores. And we'll try to play with decision scores because it's a one set of values. For each record there is one value, right? And try to see how to achieve the high precision and high recall. If you look at this example, precision recall at threshold minus 14.07 something. What is this? We have chosen one number from the decision scores we have for our data set. For our data set, each record has got a decision score, right? I randomly picked one decision score and took that as threshold and tried to make predictions. How do you make predictions? What are predictions? True or false. For every record, there should be either true or a false value. How to get true or false? If decision score is greater than or equal to that number, right? This is actually a NumPy array or a series object which actually gives you trues and falses. The outcome of this expression is going to be trues and falses. If it is true, the record belongs to positive. If it is false, the record belongs to negative, 0. So this can be used as prediction at a given threshold. And when you have prediction and your actual values, you can calculate the precision score and recall score. How do we calculate precision score and recall score? First, internally the precision score, recall score methods calculate the confusion matrix. Using confusion matrix, it calculates the precision score and recall score. Precision score is out of all positive predictions, how many are correct? Recall score is out of existing positive records in train set, how many are correctly predicted as positive. So it is going to use the confusion matrix, or internally it calculates the confusion matrix and calculates the precision and recall scores. At this threshold, we have got a precision score as 9%, right? 0.09 means 9.5%. And then recall score is 99.8%. When recall score is high, the precision score is very low, right? Just note that point and I'll explain more about that. And I have taken another number which is a little bigger than minus 14, minus 6.67. And at that threshold, I actually tried to calculate trues and falses for every record. In this decision scores, we have got m number of decision scores. There are m number of records in your train set. For every record, there will be a true or false, because for every record there is a decision score, and that will be either greater than or less than this number. If it is greater than or equal to, then you get true. If it is less than or equal less than, then you get false. So I have got predictions. What are predictions? Through true and false. That's it, right? The sigmoid function will give you one number. Either it is probability or decision score, it doesn't matter. Ultimately, the algorithm is using this expression to calculate the predictions. So we are playing with that expression. By default, the algorithm is playing with 0. We'll see that in a moment. So if I use this threshold and try to calculate precision and recall scores, I've got 16% precision and 98% recall. If you look at here, the recall reduced a little bit and precision increased a little bit. It is called as precision recall trade-off. One decreases, the other increases. Okay. At other threshold, I tried to do prediction again and then calculated the precision recall. The prediction is here. The precision and recall scores are here. And I have got 91% precision and 79% recall. Right? Recall reduced, precision increased a lot. Right? And at 0, I have got 93% and 76%. So I played with threshold and tried to calculate precision and recall. I have got 93 and 76. If you look at the logistic regressions outcome of precision and recall, see this 93 and 76. By default, it is using 0 as the threshold for the decision score. If you take the probability, right, 0.5 is going to be threshold, right? So here I played with some other numbers also, some positive numbers as threshold. The precision increased and recall decreased. At some point in time, I've got 10% precision and 98% recall. Sorry, 98% precision and 10% recall. And at 8, the threshold 8, I've got 100% precision and 1% recall. So you can make the model the way you want. If you are confused here, let us try to look at a pictorial representation of what I did here. See this? For different decision scores, I've got different precisions and recalls. The same thing with code, we have seen it. Right? So how can I get these different thresholds or different precisions and recalls, and how to choose the one way I want will be explained in the coming session. Precision and recall curve is the method which gives you all different thresholds and precision recalls at those thresholds. No need to worry about or no need to choose them randomly and play with it. We explain the concept, I chose them randomly and played with it. In coming session, we will understand how to choose a threshold for 99% precision and how to choose a threshold for 99% recall. Because some problems expect high precision and some problems expect high recall. Thank you.